The global internet does not speak English, nor does it recognize any human alphabet. Every device connected to the network, from the server hosting a website to the phone in your pocket, communicates exclusively through numerical data and IP addresses. This creates an immediate usability problem. Expecting humans to memorize a string of numbers, like 142.250.190.46, every time they want to check their email or read the news, is impossible. This split-screen layout illustrates how the domain name system, or DNS, bridges that gap. It acts as the network's contact list, sitting right in the middle to map human-readable domain names directly to machine-readable IP addresses. If this translation process fails to execute in less than 50 milliseconds, the modern web becomes effectively unusable. The journey begins the moment you type a URL into your browser. Your computer first checks its own local cache, a short-term memory of recent visits, to see if it already knows the destination's IP address. If that cache is empty, the query leaves your device and travels to a recursive resolver. These resolvers are usually managed by your internet service provider or a public entity like Cloudflare or Google. Your computer makes a single recursive query to the local nameserver. That resolver then executes multiple iterative queries across different servers. It acts as your dedicated agent, taking on the heavy computational lifting of interrogating the internet for you. Without this central starting point, every individual laptop and smartphone would have to manually search the entire global network for every single link you click. The resolver's first stop is the root server, which directs the query to the top-level domain server. The TLD server, managing extensions like .com, narrows the search. Finally, it reaches the authoritative nameserver, the ultimate source of truth holding the definitive records. These records, like A records for IP addresses, CNAME for aliases, and MX for email, dictate the domain's reach. Once found, the authoritative server hands the IP address back to the resolver, delivering it to your browser so the web page loads. Accompanying that IP address is a time to live, or TTL, setting. This tells the resolver and your browser exactly how long they should cache this information before they need to repeat the four-step journey. This combination of a decentralized hierarchy and localized caching ensures that even as billions of new devices join the network, no single server is forced to handle every request. Early internet infrastructure sent DNS queries in plain text, exposing requests to eavesdropping and cache poisoning, injecting fake IP addresses to redirect traffic. To secure data, engineers introduced DNSSEC. This protocol attaches cryptographic signatures to DNS records, verifying information hasn't been altered during transit. To address privacy, modern browsers implement DNS over HTTPS, or DOSH. This encrypts the query, ensuring intermediary networks cannot track your browsing history. Modern DNS operates as a redundant encrypted framework that executes this invisible handshake in a fraction of a second every time you go online.